get to do some harness stuff. How's that angle look?
Yeah, it's good. It's on its own.
Okay. All right, so here we go. We're into unit 6 now. A little bit about the harness as a whole. So you can see like wires. You guys know what wires do now, but let's combine it. This is a harness. This is actually a smaller, more simple harness, you must know. The wires are all bundled together, so it's kind of like the main arteries, if you will. Why do you think we put the plastic on here? Protecting from rubbing or hopefully from the mice, although they don't really do a great job. The mice will eat this too. And then we have these little clips, and this is going to help us route it properly. So if you work on a harness and you don't put this clip back in, now the harness is down here. It might get rubbed by the wheel or some spinning part or the axle. I've seen harnesses hang and rub on the belt, and the belt will, cut through all those harnesses. So the harness is basically a way to take all the wires we need, get them bundled really nice, get the connectors where they need to go, keep it out of harm's way, right? The harness is all the wires in an assembly. Sorry about that. The harness is a little wild, okay? It does all the things the wires do. Carries power, carries signals, whatever it needs to do that needs wires.
So you could say it's going to harness the harness?
I cannot harness you may need to harness the harness for me. Okay, and then when we talk about wires, I think you guys all understand. Sometimes we'll refer to it as a cable, but it's sort of like for slang, we'd say wires. But if you look right here, do you see how big these wires are? At some point, we decided to call them cables. At what size, I don't know. But if you need battery cables, they're wires, but they're big, so they're cables. It's kind of weird. I don't know where you determine when they go from a wire to a cable, but if you hear cable, it could just mean wire. It's the same thing. Cool, but we call them different. No good reason.
So it's just like a thicker gauge.
Yeah, generally, yeah. Like if you walk in and you say, I need battery wires, they'll be like, what? But if you say battery cables, everybody in the parts store knows. Kind of weird. Okay, and then generally all the stuff we're using in automotive is typically going to be multi-stranded copper core. So that means if we were to take one of those wires and cut it open, which nobody tells me what to do. I can do it if I want. You guys can see. I will literally cut it. I'll cut through the conduit, the plastic, everything. I'm allowed to do that. I'm going to actually try to cut this plastic conduit off. Some people will call it loom and some will call it conduit. Then I find a wire, and this is a black and white wire, so it's probably a ground. And I'm just going to strip the wire and just prove a point to you, and then I'll pass it around. These wire strippers are trash, by the way. They're the school's, I'm sorry. These is mine. I brought them from home. All right, but I'm gonna strip this wire just to prove to you, so much nicer. No, you can't use them, they're mine. This is a multi-stranded copper wire. See how there's a lot of little strands? That's the default. This is what we normally do. In a house, it's gonna be like a solid core wire. We might even have some aluminum wire. Sometimes the wires go together in a twisted pair, but this is your basic one wire inside of a conduit that's gonna become part of many, many wires in a harness, okay? So now you guys get to check it out. Cool. Sometimes what we'll do is we'll use really, really tiny strands. I've heard them called angel hair, and they'll call like a high flex wire. So like wheel speed sensors, for example, they go down to a suspension part, they flex up and down and left and right. They use really flexible, tiny strands and lots of them to be a more flexible wire. It's less prone to breakage when flexed, okay? So in this harness, there's not just wire. There's this type of wire, there's aluminum wire, there's this high flex angel hair wire. There could be communication wires that are specifically twisted together to reduce that interference, kind of like we were talking about with that filter. Okay, generally copper's normal. It's a little more expensive, but it's got very low electrical resistance. It remains flexible. That's good. Now the insulation component is designed to protect the wire, yes, but a big part is designed to prevent leakage of the current flow. So that little wire where we strip the insulation off, that means that if we sent voltage or any kind of signal on that wire and we strip the insulation, it could actually leak into the ground which that would be like a short. So if you're thinking about like bulbs, that would be a short. The bulb wouldn't work. It'd probably blow the fuse. But what if it was communication wires for the network? It won't blow a fuse, but if it's kind of like losing connection, but if it's to ground, it'll ground everything and the whole network will go offline. Make sense? So depends on what type of system we're looking at, that insulation should keep the signal or the power voltage inside, not let it leak out, not let it short out. Now that insulation, that's the stuff I stripped off. You know who likes to eat that, don't you? I've heard a couple reasons why. I talked to some of the wire harness manufacturers, and they used to use like kind of more like oil to pull the wire. They're pulling all these wires into one loom, like into one harness, and then putting conduit on it. They need to lubricate those wires. They used to use oil. They found that wasn't real good for the environment, so they started doing peanut oil. But I heard they use peanut oil in some of the factories. That tastes delicious, I'd imagine. I'm going to say I've probably tasted the insulation, but I don't remember exactly when. I didn't taste the peanut oil, but I think the mice can taste the peanut oil. I've also heard a lot of that insulation, they've gone to like a soy-based. It's just more environmentally friendly, and the mice love that stuff. I was just fixing a damaged wiring harness literally last night. So the mice will be eating, right? But all this together becomes the harness, okay? And so there you go. This is like a solid wire. You're not really going to see this on automotive, except maybe for like an antenna or something. It'd be pretty rare. And then here are the more common stranded wires, but you'll see multiple together. Obviously, the stranded have the strands. And then all of a sudden, you'll notice we come into cables where they leave wires and become cables. I still can't tell you, but typically, if it's like a big wire, we consider that a cable. So this would be like a battery terminal, maybe even like an alternator wire or like a starter cable. These are just bigger, similar. Then we also have printed circuitry, which isn't really harness, but I do want you to know this is part of the circuit. It's just not part of the harness. So the harness may connect in here, and then the circuit continues on these small printed boards. And we even talk a little bit about ribbon cable too, which is slightly different. And then a thing to remember, this harness does have some grounds in here, but for the most part, this is not carrying grounds. Like this one right here, I recognize. This is either the starter, the alternator. I think this is the starter. I think this is the alternator. And probably these are grounds. So if you guys can see, there's an eyelet here. The way I know they're grounds is they're white with black. And there's several of them. And so they're probably going to bolt in multiple spots. The reason we don't carry the ground as much, the floor, is because the chassis can ground it. So if we need ground in this general area, we'll run it to like the frame or to the body and we'll ground it. We don't necessarily need to run a special cable to that point. Or like, let's say we need ground back here for the taillights. Rather than run a wire all through the car, we'll just be like, we'll send positive back there, and then the ground will just come off the taillight and go like right to here. And that's why I have that ground number 207. Cool, so that's kind of how the harness works. This harness is, like I was saying, this is actually a fairly small harness, but you think this is inexpensive? These are really expensive. They're hard to make. They cost a lot of money. And every additional wire that we have to put in here drives the cost up. So the manufacturers are going to take full advantage of that chassis ground and save some money on there. And they're also going to put the smallest wire necessary. Remember, so when we get into doing repairs, you got to understand how much current is that wire going to carry. If you have a wire that's, let's just say a 14 gauge, 14, you could put a 12. 12 is bigger, right? But if you were to put an 18 in, we're not sure that 18 gauge will carry the amount of current that it needs. You can't go smaller. So 18 is smaller, correct. Yeah, and I'll show you, it's on a later slide. So the smaller number is a larger wire. The bigger number is a smaller wire. You could potentially put a bigger wire in, but that costs more money. So the manufacturers are running what it needs, not an upgraded extra, a lot of leeway size. Cool, so like there's the example of the harness. It's all grouped in. it runs where it needs to go, gets it in the general area. And then we talked quite a bit about insulation already, but here's some other, like I was saying, L is blue. L, like we've talked about it, maybe it means lavender, but wouldn't that be kind of purple? So I don't know, in Toyota land, L is blue, just the way it is. I guess you can also get sky blue. Some in translation I think was lost there. Now look at these wires. If you were to be in the jungle and a snake were to slither out of a tree and it was bright orange, you think that would be like kind of concerning? Bright colors are scary. Orange is scary. Orange is, what's it say? Hybrid high voltage wires. So high voltage means we deal with these a little bit differently. When the vehicle's powered on, we generally, the basic rule of thumb is don't even touch these. Technically though, like someday I'll do it just to prove to you it's not something to be terrified of, but just know, like if one of these had the insulation stripped, it's actually interesting. It probably wouldn't do a whole lot, but if two of them had the insulation stripped, that'd be like a nightmare right there. The whole hybrid system would shut down because it does a lot of fail-safe testing, but just understand when we look at harnesses, if it's bright orange like this, that's not your typical 12 volts. This could be 100, 200, 240, 300 volts, maybe higher. Maybe 650 volts in some cases. Cool, so orange, cool. Just don't mess with those. We work with those differently. And we don't repair those, by the way. Okay, and then a ribbon cable is another type. So it's kind of flat. You guys ever take a computer apart and see those weird cables that go in there? And it's like a flat set of cables. That's a ribbon cable. We don't do a ton of that in auto, but sometimes we do.
Like the ones that are like with the LCD screens and stuff like
Exactly.
that.
So if in the car we're doing something with the infotainment center, you may actually see ribbon cable. So the way we deal with those is slightly different. We a lot of times don't repair those either. We could. And then when we get into shielding, that's kind of what we were talking about with that noise filter. If we get unintended AC voltage and current into a wire, that can cause issues. Now, if it's something like, let's say, this ground wire, we're not real worried about it. If it's something like this alternator wire, we're not real worried about it. But let's just say this wire, I'm gonna fib, let's just fib and say this wire went to like a wheel speed sensor. Those are really sensitive to any sort of noise and interference and like fluctuation. So if we had this wheel speed sensor plugged in down there and it went past the alternator a lot of times, because it's generating a lot of power and there's magnetism involved, that can induce some voltage that shouldn't be there. One of the ways that we will prevent that is some of these things. We'll do like a twisted pair. That's pretty common on speed sensors. We'll take the wires and we'll, like DNA, like double helix, twist them. And those, because the magnetic field has to do with direction, the fact that they're twisted, it just helps them be more resistant to that. And then we do have different types of tape. This one's a little bit like metallic looking tape. And we also have drain lines, which would be, if it was that wheel speed sensor, we might run the two wires and then in the middle put a bare ground wire. And it'll just run along with it. And that would go directly to ground. So that way, let's say the alternator induced some current. It's the easiest path to ground, right? So we put a metal wire in there that goes straight to ground. It's like, oh, we'll induce right into that one. And the wheel speed sensor wires are generally clean. They're uninterrupted. They're not picking up this electromagnetic interference. Make sense? You need to know about this because if you go to do a repair and there's a special type of tape or there's a twisted pair, you can't just do your basic repair on that. It's not going to function correctly. Does that make sense? Same with those orange cables, those hybrid cables. You can't put your basic electrical tape. Electrical tape is not good to 650 volts. So just being aware that if you see basic normal wires, we can probably fix them. But if you see wires like this, and at the end I'll show you airbag stuff, SRS. No, we don't repair those. Okay, so like there's the twisted pair, pretty cool one. Again, cancels any noise that occurs in the wires. This is also common. You see what it says right here, loss of data in the transmitted signals. And you're like, data? Remember we talked about network a little bit? So if you have all these computers on a network, a lot of times, let's say it's CAN, controller area network, we'll use twisted wires to go to that module, to that one, to that one, to that one. And this tends to keep more clean signals on the wiring. Not for power locks. Power locks are not going to be so sensitive. You wouldn't twist every wire. It'd be like a sensor that's really sensitive or like a network
I
wire.
always thought that was just like flimsy, like organized.
Nah,
So
it's
it
not.
has a reason.
Yeah, it has. If you think about it, actually, it would be less wire to go the distance if they weren't twisted. If you look, twisting them is adding more wire. They're not doing this just to spend more money to keep it looking cool. Like they'll put it in the conduit if it's just to look good.
Okay.
No, it's important. That's an important detail. Cool. So like for example, here's your CAN bus. So you've got all of these, and we've got CAN high and logo in each one of them, and we twist them, and then we send them to each. Cool. So this is a potential actual wiring diagram for the CAN network for an imaginary vehicle. Makes sense? So if we were to have one of these wires cut and we were to have to do a repair, I'm not going to say you can't repair them, but you got to be really specific about making sure the twist is good. In fact, a lot of times we're not really going to repair them. That's when we'd say like, hey, the CAN bus wire's cut, you need a harness. However, if it was me, I'd probably fix it. But I do a really neat job and make sure they're still pretty twisted. I wouldn't try to put in a straight section if I could help it. Make sense? So that's all network stuff. Then here's that tape. So you can see this tape, it's twisted and it has the Mylar tape. And a lot of times the Mylar tape is metallic. Like this little stringy thing actually has a little metal wire in it too. And so let's say you had a mouse chew through this and then damage these wires. You could potentially repair it, but you should really get some of this Mylar tape and repair it and then rewrap it in Mylar tape to be a good quality repair.
You know how some wires have okay, they're like, you know, the singles, like the multiple strand ones.
Sure.
And then over it, it has like almost like aluminum foil paper. Is that a serve a purpose?
Could be two things. Sometimes it's
Like
more
inside
for.
the insulation, though.
Yeah, I've seen that too. Yes, if it's, let's say, I don't think this has one.
Or sometimes
But-
it even has like kind of like a mesh, like a
Yeah,
aluminum mesh.
those are drains. That's all stuff for EMI, electromagnetic interference. That's to keep that induced voltage from the bigger components running. Like let's say an ignition coil. If you have to run a wire by an ignition coil, the ignition coil is going to probably put out some interference. And so you could do a few different things. You could twist them, you could do the Mylar tape, and sometimes inside they'll actually have like that metallic drain line. Yeah, so you got a few different options. And it's not to say,
Extra insulation, like in a way, like.
nah. They do have tape like this that's like it's like a heat barrier type of tape. So if you see it near exhaust parts, it may just simply be like an aluminum type of heat tape, yes. But if it's something that's more near a bigger electrical component that might have interference, this could actually be, especially if you see the tape and it goes someplace and then it grounds, that's how you know that's not for heat, that's for signals. Cool. It depends. This one we can't really tell. I tend to think it might not be because a lot of times there's a little strand and they'll actually pull it out from the connector and ground it to the case. So like, for example, I don't think this showed it, but I can help you understand it. On these, if we were to cut these, don't do this, but I'm allowed to do it. If we were to cut these hybrid high voltage cables, these are 3-phase AC. If we were to cut them open around it, there will be like almost like it almost looks like, this is weird, fishnet stockings. I don't have a lot of experience. I've never worn any, but I vaguely remember it's like a stretchable thing and there's kind of like bigger, like a fishnet, and it'll be inside, and then at the end it'll branch out and it'll actually clamp to this connector, and this connector is bolted to the aluminum, so it is a ground. It's a way to get rid of noise interference.
It's almost like a fishnet. Like,
Yeah, that's a
and then,
drain.
like if you put like pull it close together, you could actually expand. Like
Exactly.
You know what I'm
Yeah. So that's to get rid of any interference or any, like rather than induce current into there, it'll just be like, oh, we'll go into the drain line, the fishnet, which easily goes to ground. Now, if you get involved in something like that, that's probably going to be like by the book, non-repairable. Now, if it's somebody like the piece of junk I was working on last night, you know, it's a friend, a ranch worker, he's got no money, and like the mice chewed a bunch of stuff in the truck, and I'm just like, whatever. I'm gonna repair everything because I'm not really worried about liability. I'm worried that he's not gonna be able to get to the other ranch in the morning, so I'm breaking all sorts of rules. But in automotive, especially when you're certified and you're licensed, like, you don't fix stuff the wrong way because you're just asking for it to come back, and then you're kind of in legal trouble. So if you see these types of things, these abnormal harnesses, these twisted pairs, these drain lines, this Mylar tape, you either A, don't repair, or B, you repair them really to the factory standard, which is why as we get further in, you'll find a lot of times people are real quick to just say, wires are damaged, needs a harness. Cool. So if the mice chewed some part like that, and we're looking at it like, well, I could fix that. It's got a drain line. It's got the special tape and a twisted pair. You know, you got to remember, it's a Dewey, Cheatham, and Howe. The law offices of Dewey, Cheatham, and Howe are looking for a lawsuit. They're looking to have the car bought back. They're looking to have, you know, the technician and the mechanic have done a bad job, and now we're suing for pain and suffering, and you repaired this wire, and then the vehicle broke down while they were in the middle of nowhere, and they had to spend the night outside, and they need therapy for the next 12 years, and they want you to pay. You know, so like what we can do is a little different than what we should do. Make sense? The go-to is you replace the whole harness, then guess what? It's not my liability. The manufacturer of the harness set the harness up. So if there was some failure inside the harness, like, you can sue them. And generally you don't really have a failure when it's like this, but you are leaving yourself to some liability when you cut it open and you try to do surgery and fix some wires. Now, I came up at a different time. So we fixed all sorts of wires. We used to fix all sorts of stuff, and generally it turned out really good, but it only takes the one customer to try to sue you. It was different. It was different back then. And to be honest, I miss those days. But I'm fine with how it is now. If some of this stuff is damaged, and it's legitimate, like, hey, we're not going to fix this because the Mylar tape or the drain lines or the twisted pairs or whatever, you price a wire harness, it's going to be thousands of dollar job. So the next thing they're going to do is say, well, you should probably call insurance company, and the insurance company's been through this 1,000 times. The insurance company will pay if it's mouse damage, accident damage, etc. Now, if there's no damage on the harness, they won't, because insurance is for damage and accidents and stuff. But generally, the harnesses are reliable, unless it didn't get connected back up and it was hanging and rubbed through, in which case that's somebody screwed up probably. Or unless you get in an accident, it's crushed or ripped, right? So it gets tricky. So we are going to do wire repair, but you got to take it with a grain of salt, okay? Like, for example, we talk a lot about the Mylar. We should rewrap those. Cool. And then this will be pretty brief because you should understand this. The wire size is very important. So you can't be putting smaller wire size in because it can't carry the correct amount of current. So for example, this is the actual size. If you were to measure it in, I think it's millimeters. So if you had a 24 gauge wire, that would be 0.22 millimeters. But if you were to almost double that, go a little bit more than double, you could get like a 0.5 millimeter. That's actually a 20 gauge. So the smaller the gauge number, the bigger the wire. If you've got 2 gauge wire, that wire is going to be 32 millimeters thick. Like 1 inch is about 25 millimeters. So if you're saying 2, that's going to be like a big, that's a cable there. That's a big wire. So for example, approximate numbers, you know, these small wires right here, you can see these. These are going to be, you can use this to size them. I don't know, maybe 18s probably. I was looking 18 or 20. 18. Okay, you see how many there are? Now look at this one. That one's not, I don't know, that's like maybe an 8 or 6, maybe an 8, something like that. So 18s, and I don't know, what do you think? 6?
I'll say a 6.
Yeah, I think about a 6 too.
It's a 6.
Okay, big difference. If you want to repair this alternator, I think it's alternator. If you want to repair this alternator wire, First off, you probably really shouldn't.
The ones to the batteries are like zeros, huh?
So it depends. They could be 2s. It depends on the vehicle. So like if it's a 4-cylinder car, they don't have to be as big because the starter doesn't draw as much amps, right? But the engineers do what we don't do. They design it, they calculate it, they figure out, what it needs to be. Our job isn't really to do the math. Our job is to be like, well, if it's got a 6, we're going to repair it with a 6. We're not going to put a 12, right? That would be the wrong way. Now, technically, if it had a 6 and you really want to do a 4, you could, if you want, you could do that. Once you start to try to fix these big cables, though, the repair is complex. You can't do like a basic crimp butt
So
connector.
it's okay to go a little bigger, not
You can,
smaller, right?
exactly. Little bigger can handle the amps and more, little smaller maybe not. When we repair those small wires, we can crimp these. When you want to repair the big ones, this is about as big as we get. If you get bigger than this, like that 6, they do have butt connectors that you can buy a hydraulic crimping tool. I actually bought one, but it wasn't for a car. It was for some big power cables for a whole house. And I bought a hydraulic crimper, and you pump it up and it crimps it, and then you heat shrink it. But generally, we're not going to really repair those. If that wire's messed up, it's going to get a harness or a new cable if you can replace it. Hopefully it's not part of the whole harness though. Cool, so overview should be pretty brief, right? And then this breaks down really the difference between like metric and AWG, but not super critical to know. Now let's define terminals, connectors. What's the difference? This is, I recognize this. This is a mass airflow sensor connector. It's one, how many connectors am I holding up? One. However, there's 1, 2, 3, 4, 5, 6 wires. Inside of this one connector that's plastic, there are 6 terminals. Makes sense? Everybody clear on terminals and connectors? The book likes to call them pins. So if this was the book, these would be pins right here. The wire comes in on this end, and the wire crimps right here, and then it's inserted into a connector. So the connector really houses the terminals or the pins. Pins are terminals. I tend to think terminals because like a pin generally would mean to me like this would be like a pin, right? Something that's small and slides in. The male would be kind of like a pin, but the female doesn't really look like a pin. You could call it whichever one you want.
Also, they're trying to say the females like the pin.
Well, they're saying in general they're pins, but I like to call them terminals.
When they're on the wire,
It looks pretty tiny.
it looks like a pin almost.
Yeah, exactly. So you could call them either one, but if you're working at a shop and they say, "Oh, we need to repair the pins on that connector," you'll be like, "Okay, cool, I got you." That means you're doing surgery. You're going to you're going to depin this. That's a term too. You're going to depin this, pull the pins out, fix the pins, and then reinsert it into the connector. You got some experience with that. So pins, terminals, all good. But the pins are housed in the connector. This is like a bigger connector that has, 40 pins. The worst one I ever had was, so this will tell you Toyota's an amazing company, but if you have a problem with, let's say, a connector, this is probably about as big as they'll go for repair. If this has about 4 wires, you can get a connector with a little harness on there. That's called a pigtail. But if you had a connector that was like this or even bigger, like this one, generally you're going to say it needs a harness. But some manufacturers are different. When I came from GM, they'd be like, okay, depin it and fix it. So you'd make a note of the connector end view and you'd figure out which terminals are all in there. And then you'd actually depin it, repair the terminals, and then repin it. The worst one I ever did was a Corvette convertible that had a water leak. And I thought it was going to be the top. It wasn't. It was actually like an when you shut the trunk, you build a bunch of pressure. There's a little flap that lets the air out. That was leaking. Water got in. There was 6 inches of water in the back trunk. And the whole, it was like a ABS and traction control computer was underwater. So the way we do that today is be like, oh, call the insurance company, and they'll be like, oh, this is going to be $5,000 or whatever. But the way I did it was like, it needs a new computer. It's been underwater, and the terminals were all rusty because it was ongoing. So I was like, rather than do a $3,000 harness, I'll depin every single one. I ended up doing 80 terminals. and repinning them into the connector. It turned out good, but as a rookie mistake, this is what I did. It looked like this. I opened it up, I started pulling them out. I made a note of yellow, red, black and white, whatever. Yeah, there was like 4 yellows, 3 reds, 12 blacks. And I was like, oh no. I just really went by wire colors. See now why I'm such a nitpicker about terminal number. When I pulled them, I should have put terminal numbers because there can be, when it's a big old harness like this, I can see 3, 4 pink wires just looking. I saw at least 2 or 3 greens, you know, so if you really want to get down and dirty, you could repin something like this. This goes to the ECM. But, you know, that'd be kind of a specialty repair. Most general techs are going to just say, yeah, if it looks like that, it needs a whole harness, you know, and whatever. It's your judgment call, actually. Cool. And then also, these connectors have locking mechanisms. So you guys have probably struggled before when you go to pull a connector off and you can't figure out how it comes off. That takes time. This one, you got to pry that one up. This one's actually a cam type. You kind of, you push a little tab down and you twist it, and that'll actually help split them themselves. So all that mechanism is in the connector. If you break one, it needs to get fixed. It's probably the plastic connector. Now you understand it's a big deal. If you break that ECM connector, you need a whole harness, and I'm telling you for real prices, it's gonna be thousands. So we gotta be really careful with these, gentle. Like this one, for example, I'll actually show you. I know this one. I gotta push down. If I try to push up on that, you see it won't move, right? Well, it will if I bang on it. But it won't move by hand. I actually have to push down here and then open it up, and that would move. So learning the connector is a bit of an art, more so than a science. They're all a little different, but that's the purpose of the connector, is to lock them together. If the connector's not locked together, what do you think happens with the male and female pins? They're got connection, don't have connection, dude, don't, right? You can have tons of electrical issues through these connectors. So be careful and also be aware. If you got an electrical connection and you follow the diagram and it goes through a connector and you find the connector's broken and loose, you probably just found your intermittent connection issue. Okay, and so there's lots of different types of terminals, like spades. Those are flat ones. We're actually gonna practice with those. Ring terminals, those are round. That's usually what goes to ground. All sorts of stuff. Like most terminals are solderless crimp-on. You know what that means? With this one, I'm actually gonna show you. This is a pin or a terminal. When I go to connect it, it's got these little open wings right here. This one is another solderless connector. If I wanted to connect wires, I would strip the wire and I would use these, and I would actually crimp them like this. You ready? That's crimped, and it's crimped on. It's just squeezed and it holds the wire. This one's a little more fancy. It's a little more like OEM style. These, I brought these from home. These are mine. These have special sizes on there, whereas this is more just like, it's kind of like, sometimes there's insulation, non-insulation, but this just is gonna squeeze it. You control how tight it gets by how hard you squeeze. I squeeze them pretty tight. In fact, if you really wanna squeeze tight, these look beat up, but these are really nice. These are like, these got some more leverage, right? These are not even really automotive based. These are Thomas & Betts. This is a little more like electrician tools. But back in the day, I used to be able to buy this in automotive, off the automotive tool truck. Mac Tools sold this one. So I got it and I'm like, this is way nice. This thing here is a piece of junk. I'm sorry. Like later when you guys feel these, I want you to be like, right, these are junk. This is, okay, sometimes the tools make the job. This is a terminal tool specifically. I have to know what size, so it actually gives me the sizes. I'm gonna crimp this at the 14 to 18, but I don't know because I don't know the wire size. And I want to show you when I do this, it's gonna roll these over, like start to do them in a circle. See, so it crimped them like that, but actually I probably really needed a smaller size. So I'm gonna do a smaller size right here, and it should roll them around, and basically I'm gonna draw it like a bow. Some of those terminals just get crushed, but the factory ones, they start kind of like this. They start like this, sort of. Then when you start to crimp them, the top is going to start to like roll over a little bit. It's going to look like this. By the time it's all the way crimped, it should be like tight. And the wire strands will be like all tight in there. That's a really nice crimp. From the factory, that's how they are. That blue thing, that red one that I did right there, that's just like a round thing, and then by the time you crimp it, it's like a flat round thing. Like this is for the audio shop. This is like a 12 volt, remote starter and radio, and that. It's all right. I would use it too, but like if you're gonna really redo harnesses, it's gonna be more like this, and it's gonna be a special tool with the correct sizing. And so the factory crimps are nice. If you have to repin something, you don't do it with this. It's gonna be this style. And you need special tools for it, and you need the special terminals and stuff. And a lot of places don't even have that. You can go to OEMconnectors.com and maybe get some, but some of the manufacturers would have a whole kit they'd send out. So like GM's was Packard, used to make the kit, and then it was like, I think Delphi, and you'd go in and they would have every terminal for every car, and you could pin all of them. Now, if you needed a plastic connector, you'd have to order it. So if you really want to do this, there's good skills in that. If you wanted to get good at this, you could go around and be like, hey, I repair harnesses, I have all the terminals, I'll contract with all the local shops, and if you got a car and the mice have chewed it and you were looking at a harness for $2,000, I can come in and fix it for $1,000. There's for sure a business model there. But I'm not telling you what to do. I'm just telling you the technical reasons that we can and can't. Oh, and then solder's different. So we're gonna solder some stuff. When we go to solder things, you're not crimping it, you're actually laying the wire on there, heating up the terminal, and then pushing solder into there, and it's like welding. It's a mini type of welding that's pretty low temperature. There's one or the other. Then this one's in between. This one's actually a crimp style, and then you heat it up with a heat gun, and this yellow is a heat shrink. It melts and seals it so it's watertight. So that's actually something I cover a little bit later. Different types of terminals. Cool. There's a spade. You see it's flat, and this is just one you crimp. See, this tool has red, blue, and yellow. Red's going to crimp it tightest. Blue's a little bigger. The blue terminals are for a little bit bigger wire. I don't remember the range. And then yellow's the biggest one, and you don't crimp it quite as far. This is actually a nice crimper. This is like what most techs have, and these are trash. Like I can barely, this gives me a bit of anxiety. These are so junky. It's like, oh, junk. But if you find a good one, they could be really nice. And then here's an eye ring, or we'll just call it an eyelet. This is funny, right? Nemo touched the butt. No. Butt connectors, because the wires butt together, and then you crimp them. Okay. And then this is insulated type. This is non-insulated. This is a little more OEM style. You see, you don't just put the wire in and crimp it. This one has the tool that's actually going to roll it over. Now I want to point something out that you have to know. Up here, that should be crimped on the copper. So this section is crimped onto the wire itself. That makes the electrical connection. These ones out here don't. These crimp over the insulation. That's to hold the insulation there. That's to make sure that you got the conductor crimped and the insulation crimped on, and that's a good job. You don't just strip the wire too long and then not have anything. This is going to protect it so you have no conductor exposed within the harness. So these are a little more technical, but it's not that hard. You could definitely do it. I'll see if I can find you some more too. All right. And then we can have some failures. So like, let's just say sometimes the plastic fails and they end up loose, but another thing can happen. The terminals can have an issue. So if we have male, female, they should have like a certain amount of tension. Sometimes the rule of thumb was, and I'm going to abuse this a bit, but the rule of thumb was, this is actually a tool to depin the connector to pull the terminals out. But they also have these tools where it's to check pin tension. So if you were like, hey, let's see if this female terminal is blown out or like expanded, you'd actually slide this in and it would be like, it would have some friction and the tool should hang in the terminal. If you go to test it and you try to slide in there and it does this, what's up with the female terminal? Yeah, exactly. So we need to replace it. Make sense? That could cause intermittent issues. That's like, I've seen cars bought back for that. You know what I mean by buyback, right? Lemon lawed. Cars that have, I specifically remember, I think it was a Kia Sedona, and intermittently the sliding door wouldn't close. So like this family was like, it's a great car, except once in a while we try to get the kids in and the door won't close and then we can't drive it. That would be frustrating, right? It was literally a loose terminal. But the problem was it came into the shop, we checked it out, it worked 100 times. We're like, I don't know, it's fine, take it. And they said, oh, we drove it for a month and then we went to leave Stater Brothers and it wouldn't close and now we're really furious, put us in a rental. You try it 100 times and it's like, I don't know, it works. Remember, it took a month to break. It might take us a month to diagnose it. And we did that about 3 times. The next thing you know, the car was bought back. But at that point, the manufacturer sent a rep out and they're like, I think it was already bought back or it might have been almost bought back, but they sent a rep out. And I remember, I wasn't on the job, but I remember that field technical specialist going with the tech and saying, we need to check all the terminal pin fitments on this. And they were over there doing the dragging test. And they got one, they're like, hey, that's kind of loose. And they actually fixed it. And I think by then the customers were already done and they ended up buying it back, but that was the root cause. Something so minor, so small. But if you don't test it, you don't really know, right? So that's kind of what we could be doing here. Another way, actually, I think it's a later slide, so I will wait, but that loose connection causes the intermittent stuff. And then connector faults, so remember, if it's got resistance, it gets hot. So if you see a connector that looks like it got hot, there's a good chance it's got some resistance because resistance makes heat. So that one's kind of getting hot. If it has a seal on it and the seal fails, water will get in. What do you think would happen to this if they were to be wet? Over time, that's what I'm looking for. Oxidize, corrodes, that's corrosion, right? That means resistance, that becomes heat, that becomes voltage drop, that becomes intermittence, that becomes potentially damaged connectors too. Cool. And by the way, these connectors get really brittle over time in the engine bay or in the desert heat too. Okay, so now let's pause for a moment. The most accurate way to test a connector. There's a lot of words right here, so I'm going to keep it simple. If I take 2 connectors, and let's just say, I'm going to fib to you right now because these don't actually go together, but let's just say these 2 connectors plugged into each other, right? There's a couple thoughts. The DIY way is this. Pull the connectors apart and then look like this. And that's okay, but let's say that the defect was happening. Let's say it was that door opener, right? That door that wouldn't close on that minivan. If that door wouldn't close on the minivan and you happen to get it to happen, the better way to do it would be leave the connector as is. Back probe this side, and voltage drop it. How much volts should it drop if it's got a good connection? 0, but what if it's dropping 12 volts? 100% that connector is no good. Then you open it up and you're like, oh, it looks like the terminal was pulled out or whatever. But see, if you open it up at first and that kind of reseats it or that clears some debris out or you see, so like the best way, don't disturb it. Measure it while the defect is occurring. And then when you get your measurement, you know, like if it's dropping 0 volts across this, it's not the connector. But if it is dropping too much voltage, you know it's the connector, you just don't know what. So your next step is like, what's up? And then you'll know, right? So it sounds crazy, but you guys just got to understand the way this business is now, people are trying to get their cars bought back. It's at like an all-time high. One of my former students just got hired to help combat these lemon law things. They just passed a new law. I don't remember what it was, SB something or other, state law, saying that the manufacturer now has 30 days to respond to a lemon law buyback. So if they're getting hammered with lemon law buybacks, the dealer's got to document, the dealer's got to do their notes, the dealer's got to send the stuff off to the manufacturer. The manufacturer only has 30 days from when that complaint is filed to say, we're going to buy it back or we're not going to buy it back or whatever. So like the buybacks are on the rise. Even if the cars aren't getting worse, it's just people have buyer's remorse. You go buy a new car and then you're like, man, this payment is $800, $900, $1,200 a month. I don't want it anymore. complain about something random, and if they don't cross their T's and dot their I's, I want a buyback. Boom. Makes sense? That's happening for real. So you got to really go about it in a different way if you're going to be working on newer cars that are like under warranty. It's just a totally different, it's just different than you see, oh, that door's open. If they want to come in, they come in. Okay? And then another test is the wiggle test. Now, have you ever done the wiggle test? Okay. Now, the wiggle test would be like this. Let's just say, this is helpful. Let's say it's a light bulb. Let's say it's a headlight. If the headlight's on and I wiggle this and it goes off, and then it comes on and it goes off, what did I find?
Problem.
Right here, exactly, right? It's not rocket science. Those methods still work.
Yeah, but when it's loose and stuff, when they get loose, right?
Exactly. And if you do the wiggle test and it induces the problem, you're like, all right, I found it, right? So one was technical with the voltage drop, the other one's just wiggle test. You'll see me, if I got a problem intermittently, I'll be grabbing the harness and moving it and wiggling it, and I'll be like, and if it's a little more technical, let's say it's a sensor reading, I'll pull up the scan tool, I'll look at the sensor reading, and while I'm looking at the sensor reading, I'll do the wiggle test. Sometimes I do a couple wiggle tests, right? But the wiggle test is legit for all ASE areas, but originating with electrical. Cool. And then you can see, like, when we get into pinning and depinning, I want you to notice sometimes the terminals come through this way, most of the time. Other times they're really a hassle. The way they do it from the factory is they slide the wire through and then you crimp it and then you pull it through backwards. Those repairs are much more difficult. But kind of less, this is a little more typical. If this female spade failed the wiggle test or it failed the voltage drop, we could fix that. You know, we could actually unpin this from the, there's going to be a way, like there might be some tab. Sometimes the terminal has a metal tab that you have to bend out of the way and then slide it out. A lot of times the plastic has a little tab you temporarily push out of the way and then slide it out. But that's why I brought these tools. These are terminal tools. And this one's fun if I'll show you this tool. This one has a piece of tape on it and it's broken. And it says, Dad broke. So my dad broke that and put it back in my toolbox. And he told me he saw these tools and he needed like a little screwdriver. And these are not damn screwdrivers, Dad. It may look a little bit like a screwdriver, but these are specifically for sliding in and unpinning. The screwdrivers were in the drawer
Like
right
my
next door.
husband, when he gets a flathead and he tries to unscrew a Phillips.
Oh,
he
dear.
pulls the tips, like,
You tell him I called him a primitive Pete. And if he doesn't understand, you show him that video, that
He's good
ABC.
at taking things apart but not putting them. He'll always have extra screws.
Makes sense. There's a lot of them.
Pry bars.
Primitive Pete. Yeah, they're all pry bars. So if you guys want to fix these, you guys can imagine. The goal is to unpin this. Then you could potentially put a new spade on there, and then you could put it back in, right? And you could fix the car. You could do like a save the car from being bought back. This type of work is critical.
They have them kind of pieces for that. I mean, where do you get them from?
Yeah, I'll show you. We have some. It depends on exactly where you're at, but OEMconnectors.com is like a new thing. But back in the day for me, my dealer, the GM dealer, had drawers and drawers and drawers. This type and that type and this type and that type and that. You can get them. They can be hard to find though. But if you want the whole connector, it's a fortune. But if you want just the terminal, dirt cheap. Like these gold ones I got, this is how I build I was doing a lot of dirt bikes, making them road legal. I bought like 100 packs of these for $5 from China. And they're all made in China anyway. So these are dirt cheap. But because that terminal fits every connector that has that terminal. Whereas this connector is like specific. So it costs a lot more to build when there's so many different molds. Whereas these terminals, they just pump them out all day. Cheap. You can get them. Oh yeah, you'll get it. Okay, and the other thing is, this is the male connector and the female connector. However, this is the female terminal to the male terminal. So this gets kind of weird. On the wiring diagram, if it shows that that chevron signal, they're talking about the connectors, not the terminals. So that's a little bit weird. If you pull this out, you got to know what's male, what's female. This one's a male terminal and a female connector. This is a female terminal and a male connector. Kind of funny, huh, to think about. And they usually are like that too. All right, and then when we go to and what we talked about, like if the terminal's spread and you need to fix it, we could use the terminal tension checker and see if it falls back out. But if sometimes when they insert the pin or the terminal, it doesn't click all the way into the plastic or the plastic's broken, that would require replacement too. So like for example, this crimping is loose, that could cause an issue. For example, this one is not connected all the way, maybe because the lock is broken, major issues. This one is connected well, but when somebody did the work, they didn't have the harness in the right place. It looks like they twisted it up. That's going to be trying to pull these terminals out. Eventually, that's going to cause a failure. So that would be no good. And these are the actual terminal checkers. So you'll notice 0.025, so 25 thousandths of an inch. That's to check that particular terminal. What would happen if you had a terminal that was for 25 thousandths and you shoved the 30 thousandths in? Yeah, now you just killed it. So I worked with a guy. I'm pretty sure he doesn't watch YouTube, so we're good. Every electrical problem he would diagnose, like he couldn't see that well, and I remember seeing him over there squinting and stuff. And I remember like when he would go to do a test, he'd be kind of like shoving a pick in there, and the pick is not that small. He'd be like shoving his pick in and then trying to test it, or using the meter lead. And the cars would come in with something like the tail light doesn't work, and then by the time they would leave, the license plate lights don't work, the brake lights don't work, but because he was trying so hard to test it, exactly. And it was, and some people told him like, dude, like we saw you with the pick over there. We saw you shoving that thing. And he's like, no, so my job to tell you, you have to be conscious that the terminal fitment is critical. You will ruin the car because those are so hard to find. Imagine going behind that guy and finding loose terminal after everywhere he went. It's like breadcrumbs, except bad and not helpful at all. So don't be one of them. Don't be doing that. Cool? And then as for the harness itself, broken wires are pretty easy if you can see, but a lot of times you can't see where it is, you don't know where it's at. So test first. Remember, engage brain before hands. Test it first. If you know it's on that wire, try to narrow it down the best you can. And then if you know for sure it's between here and here, then yes, open it up, look for it, do some surgery, find it, okay? But you can't only use your eyes. You'll never find the problems if all you know how to do is just look, right? And then also if we had a short, you may find things like this, like something obviously rubbed through that. Why did it rub through it? You got to figure that out. Maybe it wasn't routed right or something. Also, if it rubs through and it hits a bracket or like a holding locating clip, that could short it to ground, right? So if we have these symptoms, opens, high resistance, shorts to ground, it all comes back to the harness, really. So if you kind of want to have a zoomed out view, like if you got a short to ground, we're looking for a spot that's maybe rubbed through. If you got an inoperative tail light and it has no voltage, we're probably looking for open. Probably this guy did it, or something. Yeah, that's what I'm saying. They do it though. They do. They cause some damage. I'm gonna tell you right now.
Yeah.
So considering it could be, and hey, it could be that the customer ran something over in the road and the tire kicked it up and it cut the wire going to the wheel speed sensor. These things happen. So sometimes I like to zoom out and rather than bust out that wiring diagram and trace everything and get my highlighters I'm just sort of like, okay, this has symptoms of an open. Let me visually look and check this harness, and if I see some existing damage, I may start with just inspecting the damage rather than testing so much. Makes sense? But if I don't see the damage, I got to resort to testing for sure. Cool. And then here, this is a really good picture of, do you see these little wings right here? Those are the pieces that lock it into the terminal. So when we go to remove those, actually, this is the tool for that. This tool is round and hollow. It's almost like a straw. The straw is going to slide over and depress those wings, and then it can pull out. Make sense? Whereas if there's plastic right here, you see that wing won't let it back out unless you squeeze them in. But if you try to go in there with your pliers, you're going to be, that's like getting a pedicure with a chainsaw. You got to have the right tool for the right job. Cool, so that's kind of the trend. And then you guys can see really well here. This crimps the conductor and this crimps the insulation. I really like that picture. And then when we want to talk about removing a terminal, I just got a picture slideshow that I blew up so you can see. So we're going to pull the connector. Right here, this is sometimes called like a terminal lock. Pull that terminal lock off using this special service tool, which my dad thought was a flathead screwdriver. There's a specific way to unseat that. And if you know the specific way, people think you're magic. And if you don't, you're poking and you're prodding, and next thing you know, it looks like you tried to eat the connector. That's how you know you don't know. So this one, I remember these connectors actually. I wouldn't be surprised if this one has something similar on it. But on some of these connectors, there's a little, actually this one's really good. On this connector, you guys can maybe just barely see, there's a tiny square cutout above the terminal. I know for sure that's to make room for the tool. So I'm gonna do something along the lines of this, okay? I don't think I have the right terminal, but when I push this in the right spot, and then I'll pull, it'll unseat. But I have to have the connector lock removed first. This is like surgery right here. And if you're good at it, you're really good. And if you're not, you're gonna make a mess. And today, you're allowed to make a little bit of a mess, but as minimal mess as possible. But if you really wanna get good at it, it takes a lot of practice. Okay, and then we'll pull it out right here, and you can see, you notice this blue thing? What do you think it is? That's the seal. So that prevents water from coming in through the back of the connector and corroding that terminal. So if we repair that, we need to make sure we got the seal back on there. You'll also notice that seal is clamped onto the terminal. Sometimes those terminals have extra big wings, and that's to go up around the waterproof seal too. There's special tools for that as well. Cool, then we gotta pull the terminal, and a lot of times it'll give us some specs on like what tools, what terminals. You can dig that out of the manual, right? And like this one's really nice because this one will show what type of wire it is, what the terminal is. It's a 1.03 non-waterproof. There's the terminal. It gives you all the measurements, and a lot of times it'll get you a part number. Right here, 90980-1222-6. So if we were working on a front door lock motor assembly, here it is. You need to replace the terminal, there's your part number. Roll into the dealership or whatever and say, this is the part number I need, and they'll get you that terminal. Cool, so it is doable, it's just hard. It's like anything, it's hard to get the information, I admit. And also it tells you how to do the lock. So see right there, you see that? You can just barely see it, but this is plastic and white and it drops down. What I need to do to release this, not this way, because see the arrow? I need to come over here and I need to bring this in, and I need to actually, I need to pull this up. See that arrow? You can barely tell it's up. So I need to bring it in and catch the edge and lift it and then pull it out. So this gives you the information on how to do it, but I totally admit it's hard to find this information, but I'm showing you it does exist. Okay, and then we talked quite a bit about wire harnesses. I think we're probably good. Remember, some of them are inside, some are outside. A lot of wires, and they're always going to go to a terminal and into a connector. In the engine bay, around the dash, inside out, they're all over. Cool, so there's a good example of one with some connectors. We're probably pretty good on splices, but splices can look a lot of different ways. If you wanted to do a splice, we could actually bring multiple wires into this and crimp it. It could be that simple. Other times, splices are brought together and they're soldered. You know, they can vary, but you know what a splice is? It's where they just join them. They can look one way, they can look another way. I've also seen one where it's terminals of a connector, and this is something I just thought of right now, so I should have actually got a picture, but let's just say we had this connector and we brought in here 10 grounds and it's all pinned out like a connector. And then what they make is they make one piece of metal that'll actually plug into every single terminal and join them all together. I've seen that on like, especially Chryslers, it's called the star connector. All the network wires will go to one connector like this, and you actually plug that in, and that's what gives the network communication with all the other modules, right? So, but that's a type of a splice. They call it a splice comb, like I used to comb my hair. It's been a while, right? Splice comb. Cool. And then here's ground terminals. Go to chassis. This gives you a little bit more information about if it had an aluminum wire. A lot of times it'll give you some indication. In Toyota, if they're LA, they're lavender. Those are aluminum, and the tracer can vary, but the main color will be lavender if it's aluminum. And SRS wiring. You know what that means? Supplemental restraint system. Airbags. That's big time liability. If you thought that you repaired this harness well, but you didn't, and the airbag didn't go off, and they get in an accident and someone's hurt or killed,
That's on your case.
you in big trouble. And that's why generally we say we don't repair these. A fun fact on these SRS harnesses, the actual terminals are literal 24 karat plated gold. They're a little more money. But gold's an amazing conductor, so we will sometimes use gold for those. Scrape off the gold so you can pay your retirement, huh?
No, to buy more Jeep parts.
Okay. You would. Okay, but now you know what? I'm gonna jump in because I want to make sure I get to cover how we repair. So here's stripping the wire. You can see we picked the right wire size. And kind of like crimp it on there and then spin it around, and that'll cut the wire, and then pull it and it'll slide it off. Not hard, right? You can see that? Now the copper wire is exposed. Nice job.
Have you seen the strippers where they're
Yeah.
automatic?
Yeah, some of those are okay too. Yeah, they can be all right. And you could strip the wire incorrectly and leave some insulation. Imagine if you left the insulation, you crimped over top the insulation. You have a good connection?
No.
You have no connection. Yeah, so that type of stuff happens. We've also seen where you go to strip the wire and you actually cut off several of the strands. That's kind of like in the next page it says a choke point. You had a 12 gauge wire and now it's an 18 because you cut some of the strands off. Makes sense. You gotta get good at this. Cool. There's the solid wire. We don't deal with that typically, but that's house stuff, and that's got a little corrosion.
That one breaks easier, huh?
If you try to bend this, it's absolutely going to break, and that's why we can't have it in automotive with the vibrations and the bumps and the movements. This is
Find on your light sockets.
exactly house. We'll pull all that stuff in a home for sure. Now solderless, real quick. These are crimps. So if you were to do a solderless crimp, they generally don't come with a waterproofing. This one would be the exception, and I do show a picture of this. But if you do a solderless crimp like this, yeah, you crimp it, it makes a good connection, and then water gets in and ruins it over time. So one, electrical tape, which you could do. This is fine. I would never crimp over a male-female spade. Like, this is kind of janky here. A better one would be heat shrink, which I think I have on the next page. This is actually a good thing. The liquid electrical tape is pretty cool. Especially if a wire's just nicked, you can put liquid electrical tape and that'll re-waterproof it. But nothing's quite as nice as the heat shrink tubing, which is on the next one. And here's a crimper with insulation and without have different crimping locations. The tools that I have are just one, and I control it. So if it's non-insulated, I crimp further. And if it's insulated, I crimp a little bit less. But I still crimp pretty hard, I'm not gonna lie. With a good tool, you could crimp it hard and it won't cut. With something kind of janky,
Those are janky.
that might actually cut through it. Like if they're sharp, it'll actually cut through the connector. So you need to get something that's decent if you want to have success. Here's those solderless ones, right? So pick the right size. The blue ones are like the mid. The yellows are larger, and the red, and they should be labeled when you buy them. What wire terminal?
With a little disc of solder.
I'm going to show you that. Yeah, solder ones, yep. So there, that one's stripped. This is about the right amount, and then we're gonna twist them a little so they're not all crazy. Insert it, crimp it. Everybody's gonna get to do this. Now, why not down here? That's for bare, that's not insulated. I do it anyway, but I'll go with the publisher. Yes. Okay, and then there's a non-insulated, right? We're crimping that one, but this is actually not a real good quality repair. These are not the correct tools. This is. This has the correct tools to, this has the correct profile to fold them over. So this is actually straight out of the book. It's just, a lot of people aren't really that good at this, to be quite honest with you. I've seen a lot of techs and they're like close enough, you know, like I would recommend you get good at this. I mostly got good at it when I was building all these bikes and I was selling bikes and I was profiting good money and I was making nice, people would look and they're like, this bike came factory street legal? I'm like, no, that's a dirt bike with all the stuff I added and it looked legit. I even been pulled over a few times and the police are like, what is this thing? I'm like, it's a 450X. And they're like, I thought it was a dirt bike. I'm like, oh no, here's the registration, you know, like that. It was legit, but I had to get it through DMV. So get good at it. Here's heat shrink tubing, my favorite. So let's say that you want to insulate that. You get this tubing, slice it, slide this over, and then watch what we're going to do with the heat gun. Put the wire through, do the repair, and then heat it with the heat gun, and this will close up, and this can be totally waterproof. That's a good repair right there. And this stuff is cheap, too. It's cheap, it's just, it's not necessarily what you find in the electrical tape aisle. You know, it's like you can pursue it and you can get it and it's great. And we have quite a bit too. And then these ones, straight from AutoZone, but if it were me, I would buy them on Amazon. You can get these cheap. 3M used to be the only ones who made these and they were like a couple, like $2 to $3 each. You get them cheap now on Amazon. So this is red, blue, yellow. This is a yellow one that I brought in person. You remember how we did that whole butt connector? Strip it, twist it, slide it in, crimp it, and then afterwards, it has the heat shrink already on there. You just heat it up and this one seals up. The reason I like these better than the heat shrink itself, they're sort of clear. So when you do it, and you can still see and make sure nothing pulled out or anything, these are really nice. But I don't have a lot, but we'll at least do one together so you can see it. Maybe I'll bring in my Amazon ones and just have you get to practice a little. But you can see they're for sale. And then this is the one Michael was talking about. This is not crimping. This is cut, strip the wires, slide them in. And right here, there's like see this little bulb of solder? It's like a disc. It's like a ring. You get this wire in and this wire in. They have to overlap. You don't crimp anything at all. You just hit it with the heat gun and the solder will melt and join the two wires together. And then these become the water seals here. That's a nice one too. These are a little bit pricey. Depends on some manufacturers recommend one and some the other. Now we end with really soldering. So we'll talk a bit about solder right here. So if you're gonna solder, this is a soldering tip that's been cleaned and what we call tinned. Tin is when you take the solder and you melt a layer onto the tip. This needs help. This needs to get cleaned. One of the ways that you can clean the contaminants is flux. So you can buy solder with flux in the inside, and it kind of self-cleans, or you can buy flux and like brush it off while it's hot and it'll clean it really good. And this one's been cleaned, but it hasn't been tinned yet. You could probably solder with this, but if you actually coat it with the solder first, it gives it more surface area to contact the wires. The heat passes more quickly into the wire, and then the solder will pull into the wire like quickly, much more quickly. So here, we're tinning this one, right, coating it. And then right here, I wanna annotate this a bit. If we lay the wires across this and you twist them together, they kind of hold themselves. Then what you want to do is lay the wire in the blob of solder that's kind of liquefied on the tip of the iron. Let it get hot, and then when you send the solder in, your solder right here, this is not a great job, it's not horrible, but your solder right here, you should not be melting it with the tip of the soldering iron. You should be letting the hot wire melt it, and the solder will always go towards the heat source. So if you put the heat on the bottom, I'd actually put the solder on the top and let it pull all through the strands, and then pull the solder off, remove the heat, and it's nice. It turns out good. What I've seen many times is people lay this out and then they like put the solder there and they try to mush the solder around with the tip, and they're just kind of like encapsulating it. It's sloppy. If you do that, I'm kicking you out. Just letting you know. And if you can get good at this, you know what you can also do? You can solder pipes, or like sweat pipes. It's the same thing. Sweating the pipe, you're going to heat it, probably not with an iron, but more with a torch. And then same thing, you're going to let the heat draw the solder down into the joint, and you can like do some little bit of pipe fitting too. Same concept. Cool, so there's what I would do when you get ready to solder. Just do a little twist like that. You don't want a big old blob. If you got a big old mess, that's going to be like, a spot where wires can rub. Your harness is going to get ugly pretty quick. So small is good. There's doing the solder. That's actually a pretty good solder joint. It'd be nice if that wasn't there. If you really wanted, you could actually file this off and make it really clean. Because remember, we got to slide the heat shrink on.
Clean it up with the solder.
True. I was seeing the strands right there. If you can get it cleaner than this, there's less likeliness that you're going to slide the heat shrink on and have a wire poke out or have the heat shrink get ripped. Makes sense? So that one's okay. It was a nice solder job. It was just the wrap on the wires wasn't as good. Okay, and then there's the heat shrink on there. That's a nice repair. This is a repair that I would warranty. This is, well, they're not really centered, but still pretty nice repair. This is legit. You know what's not legit? Wire nuts. On a car, straight to jail. Twisting the wires and taping them. No. Yes. See how that's different? That would hold up. That's a good repair. Okay. With that, you guys are good to take a break. And we'll do some lab work when you get back. All right. We're going to do a couple of wire repairs. Yes, that is a soldering iron, and yes, it's warming up. But right here, I've brought my own crimpers that I like. Crimpers and strippers. The Thomas & Betts special. So we're going to do a couple things here. We're going to strip this. And if I look a little awkward, it's because I'm watching through the screen, which is just a little abnormal for me. And pull. Actually, it might be just a little bit small. It might be like a 16. Okay. Ooh, this wire is aluminum. This is going to be a little difficult to solder, but I'll make it work. Okay. So you see how I'm stripping the wire back, but this is going to be for a butt connector, so I don't want to overstrip. Okay, then I like to give it a little twist. Now this is the correct butt connector for this size wire, which I thought was it's right about a 16. All right, so I'm going to hold that, and I'm looking to make sure the wire is pushed all the way in. And in here, the wire will actually bottom out on that little nub right there. All right, and then from here, I'll go right to there, and I'll crimp right about in the middle. Right in the middle of the left side, so kind of like at the quarter. And I just squeeze. This is a strong squeeze. I squeeze pretty hard. All right, and that one's good. Now, I also want to show you this other crimper that I have, which I left on the other side. So I'm gonna just continue with this one. They have cheap crimpers and they're junk. This is actually a pretty good crimper. So same things. Twist it, insert it, hold it, crimp it nicely. If it's a good crimper, you should be able to squeeze it hard and it should not try to cut through. So you'll notice this is what a good one looks like. Technically, this is supposed to be for insulation. That's trash. I don't use that. I use the point every time. Crimp's nice. It's strong. Then the next step is it needs to be heat shrink. I'm spinning it. And I'm going to do this from left to right. You can do it any direction you want. But you see it shrink up. And that's a waterproof, permanent, nice crimp, good butt connector repair. Again, very strong. Okay, so that's one option. Another option has to do with what I've been doing here with the soldering iron. So I'm gonna use another similar piece of wire. Now, I did not realize this was aluminum, so it may fight me a bit, but I've successfully soldered a lot of aluminum. It just takes some patience. Cool. And actually, I just caught myself. When I'm gonna solder, I like to give about double the exposure on the wires. So I have plenty of space to work. And before I forget, let me spin that up and let me take my the heat shrink I want to use. Get about that long. Slide the heat shrink on. Once you solder it, if you've forgotten the heat shrink, it's too late. All right, same with this. Okay, and then when I bring them here, I'm going to cross them right about there. And I'm just going to give them a nice tight wrap. A really nice tight wrap. Cool. All right, and then I don't always use this, but I've got it here, so why not? Get the heat shrink far away, otherwise it'll prematurely heat and shrink. All right, move my iron a bit. Okay, that's good. That's good. Now I got a really nice workstation, and let me give you the 1080p. It's actually way more. This is in 4K, 60 frames, really up close. If I can get it to focus just right, I want to really be able to show what I'm doing on this. Okay, focus on that, baby. Now be nice to me. All right, this is a rosin core, with flux solder. What I need to do here is bring the soldering iron up. It's been on for a bit. It's a bit dirty, but what I'm going to focus on is tinning it up right here. As you can see, I just got a nice liquid puddle there. And then I'll make the contact, set it right in the puddle. And I might drag the puddle up a bit, but I'm trying to get it to really heat the wire right there. That's beautiful. Okay, and it does seem like it's not wanting to stick, and that's pretty typical of the aluminum. So a flux would probably help somewhat. Okay. But if you notice, what I didn't do is try to set the aluminum on there and set the solder on there and then just try to melt the solder with the iron. I'm using the iron to heat the wire, and then I'm letting the wire pull the solder in. Okay, that's my goal. And that part is critical. So that was aluminum right there. Copper, my copper work is going to turn out even nicer and cleaner, but that should be there. That's still a little bit hot, but it's strong. Cool. Then my next step, it's a little hot still, is going to be to pull the heat shrink over. Right, and what I'm looking for is that the solder, ooh, there's an ugly one right there. So actually, let me neaten that up. I really didn't see that. All right, what I'm really looking for is the solder needs to penetrate all the way through. Right, and that's why I was spinning it. So that's soldering aluminum. It's not that easy. Pull the heat shrink over. I'll do a quick heat shrink. Okay, so that's another acceptable repair right there. Turned out nice, strong, waterproof. Let me show you aluminum or copper real quick. All right, this will be basically the same, but let's see, it'll go a lot nicer. Sorry, I know it's a little tough to see, right? But tight wrapping is important. And then make sure I can get this right where you can see the details. In fact, I really only need one hand. All right, let's see if you like that. Decent. I could get better. Okay, here we go. All right. Same thing, tin up the iron. Now you'll notice, what I don't want to see is this, like that janky business, okay? So make a puddle, immerse the copper, and then watch. Now you'll notice the copper just started, the copper itself is actually the part that's melting the solder. Now you see how it's bubbling up? Actually, this probably has a little contamination on it too, actually. I don't have a whole lot of feeling, so I can do that. Okay, so now what I'm going to do is zoom you in. Again, looking for really good penetration on there. Zoomed in. I could probably add a little. It's interesting because through my phone I can actually see it more up close than in real life. So that's kind of fun. Cool. Now, pulling hard is looking good. Now let me give you what it really looks like. Somebody be like, oh yeah, my solder works so clean, but you saw how it was when I really zoom in. Right, so that's how you do it. You can see that's hard. Good repair, that one's non-waterproof. But wait, there's more. All right, so now the focus is gonna be not joining wires, but terminal repair. So let's just say we had an issue with one of these terminals here. I'll walk you through how to get it out. Now I haven't watched or referenced any of the instructions, but I've seen connectors like this, so I'm pretty confident. First thing I need to do is pry up this piece and remove it. Yeah, there's a little mosquito. And then, and this part's really hard to see. I gotta see what holds it. And I think I just barely caught a glimpse of what's holding these in. Right up here, there's a tiny tab. All right, right, just barely in, right about there. Yeah, you can see it. Just barely. Okay, and they do vary, so this is just an example. If I hold it right here and I zoom, oh yeah, these ones are mangled. So this must have been one of the student practice ones. So check it out. Right about there, there's a piece I need to pry up. So this is the trick. I'm gonna put my fingers here, but back here, this is my pinky. I'm gonna tug on the wire just a bit. All right, so let me show you what that looks like. So right here, what you got to see is I'm tugging on that red one. That red one's the left one, but my other fingers are holding it. Okay, so here we go. I gotta go up there. Oh, you know what? I think that red one's broken. I gotta go the green one. This is one of the practice ones, although not for me. Okay. Right there. See that tab, buddy, right there. If I get that tab and I pry it up, which I'm gonna try to get you a better view as soon as I get it. You could see it there in the shop pretty well. Yeah, this one got a little rough. It's tough for me even, but not usually this tough. Really rough. And these are definitely not meant to be redone over and over. Grab a fresh one.